Hi, physics students. Welcome back to my Digital Academy students. This week, we are going to be moving into graphing different types of motion. So we're going to look at two different types of graphs. We're going to look at distance versus time graph and velocity versus time graphs. We are going to learn how to read the graph, what kind of information we can get from the graph, and then we're also going to do a lab in which I'm going to run different types of cars to show different types of motion, and you're going to gather data from that. I will have it in two separate videos, so we're going to get started. The first video is going to be on the actual notes. So you will need the graphing motion notes in Schoology in order to follow along. I'm going to pause it for a second. Okay, here we go. Up at the very top is a review of our variables that we learned last week. Next week, we are going to actually get into the different equations that use these variables, so you need to know what they're measured in, the unit, and what they represent. So delta t always is time. It is measured in seconds. Delta x is the horizontal distance, and that distance is always measured in meters. X on a graph is horizontal, so delta x will be our horizontal distance. Delta y is vertical, so that will be the vertical distance, also measured in meters. The initial velocity will be vi, the final velocity will be vf. Both velocities are always measured in meters per second. And then finally, A stands for acceleration, and the units of that are meters per second squared. Give yourself a quick quiz. You had the variable practice quiz last week, but just try and fill that in and see how many of them you have memorized. All right, knowing the basics for graphs. When in physics we look at a graph, the quantity listed first will always go on the y-axis. For example, distance versus time graph means that the distance is going to be on the y-axis. So as you're setting up a graph, if it was distance versus time, I'm just going to use this graph down here in the corner. If it was distance versus time, distance would go on the y, and you always have a unit that it's measured in, and then time would go on the x because it came second. Also important to always have a correct unit when you're making graphs. You want to make sure that you label them as well. I'm just going to quickly erase that and get back to it. All right, what does it mean when two variables are related different ways? We have directly related, and then we have indirectly or inversely related. Directly means the two variables do the same as each other. They do the same. So if one of the variables goes up, the other variable also goes up. An example on this graph over here, the line, that is the A line, that is an example of a direct relationship. As this variable is increasing, this variable is also increasing, which gives it that positive slope on the graph. The opposite type is our indirectly or inversely related. This is when the two variables do the opposite. So they do the opposite. If one of them goes up, the other goes down. The example on this graph right here would be B. As this variable is getting bigger, as we're moving that direction, this one is going down. We kind of have that downward slope for that type of graph. We will have to be able to look at a graph and look at numbers off of it in order to calculate different things. So looking at the graph off to the side over here, the velocity versus time graph, we're going to have to be able to calculate a slope. Line 1 is just this part right here. When you're looking for slope, it is the change in y's, y2 minus y1, we just put delta there instead, over delta x, the change in the x values, x2 minus x1. If you look at the y values, I forgot to get a 0 in there, just imagine that it's there. We've got a 10 up at the top at the end of line 1, so that is going to be 10 minus 0 was our starting place. And then for the x portion of it, it goes up to 5 when we get to the end of the first line, minus 0. That gives me 10/5. You can leave it in fraction form, or you can just divide and the slope is equal to 0. we are gonna look at that and we're gonna learn the actual units of it. We would have to put a unit behind it. We're gonna find later that it's meters per second, which is the same as meters per second squared. At 6 seconds, how fast are you traveling? So you're gonna look over here, here's 5 seconds, 6 would be a little bit higher, we go up to there or so, and we look and see that we are traveling at 10 meters per second. Are you moving faster at 3 seconds, which would be, let's say right about there, or 7 seconds, which would be right about there, moving it up, you are moving faster at 7 seconds. And then lastly, we are going to have to be able to look at a graph and be able to find the area underneath the graph. And we will do that by, if we can break them into shapes, we're able to do it using mathematics and geometry in order to do that. So for this guy right here, we're going to break it into 2 different shapes. We want to find the area under the line. We can break it into a triangle. And then the other one is going to be a rectangle, like that. All right, starting with the triangle. The unit, or the area of a triangle is 1/2 of the base times the height. So we're gonna take 1/2, the base of the triangle is 5, the height of the triangle is 10. So if you take 10 times 5 is 50, 1/2 of that is 25. Going into the rectangle, the length times the width, the length starts at 5 and goes to 12, so you have to subtract that and you get 7. And then the width of it is 10 from there to there. Multiply that and we get 70. To find the total area under the graph, we just have to add the 2 of them together. So 25 plus 70, and we get a total area of 95. We're going to learn the units of area under the graph are going to be meters. We'll get to that here in a little bit. Okay, learning how to read what is happening on these 2 different types of graphs. So you have to know in a distance versus time graph, this side is distance and this side is time. I labeled the units that it's measured in, and then now I'm just putting the distance and the time. Okay, so if you look at line A, as it goes from there to there, what it's telling us is that the meters, or the distance, is increasing. Maybe you're moving towards something, maybe you're moving farther away from it. In this case, if your distance is increasing, you would be moving, the distance is getting higher, there's more distance. From there, part B, your meters are not changing, they're remaining constant. If that is happening, what that means is you're not moving. You're staying in the same spot, you're standing still. Those are kind of different options for that. And then finally, C, that is showing your distance was, let's say it was 60 meters. Your distance is decreasing, it's going down. So maybe you are moving back towards where you started, so the distance is decreasing. That is a different type of graph than the one over here. This is a velocity versus time graph. On here, the velocity measured in meters per second, if you start at 0 and you start moving faster for line A, it is showing that you are speeding up, you're increasing your velocity. So I'm just going to write speeding up because it fits better. When you get to part line B, it's flat, it's that horizontal line. It's showing you that the velocity is remaining the same the entire time. So you're moving at a constant velocity. I'm just going to abbreviate velocity. And then finally, line C, it is showing that you are slowing down. Your velocity is decreasing, so you're slowing down. All right, those are going to be the different types of graphs that we're going to look at. We're going to get into those in a little more detail here on the back side of this. So if you look, we're going to go back to just one at a time, a velocity versus time graph, or excuse me, Distance versus time graph. We've got distance on the y-axis, we have time in seconds on the x-axis. If you were to take the slope, slope is the change in y over the change in x, which means the units have to do the same thing. The units of the y are meters, the units of the x are seconds, so the unit for the slope is meters per second. We know from last week that if you're measuring something in meters per second, you are measuring the velocity of that object. You will have to be able to calculate the velocity, which just means that you have to be able to calculate the slope. So we got a car driving and the distance versus time graph is shown below. Calculate its velocity. Remember to put the correct unit on it. In order to find the velocity of this distance and position are the same thing, a distance versus time graph, you are just going to find the slope. So we have to change the change in y over the change in x's. So the change in y, it gets to 50, it starts at 0, divided by the change in x, it gets to 5 and it starts from 0. So I have 50 divided by 5, which is 10. And then because it is meters over seconds, that is the unit that we'll put behind it. Our other type of graph is a velocity versus time graph. The unit for the slope, if we take the change in y over the change in x, we are going to take meters per second, divide it by another seconds. I showed you last week how this turns into meters per second squared. It's because the seconds on the bottom, you have to multiply by the reciprocal to get it off the bottom, and nothing cancels out and it turns into meters per second squared. That means it's telling you the object's acceleration. All right, the area measures something completely different. So if I wanted to find the area, that's when I'm going to multiply the velocity. So I would take 1/2, if this is a triangle, of the base, which is time, times the height, which is velocity. So I am going to take the units of velocity, and I'm going to multiply them by the units of time. I should write that better. Meters per second times seconds. If you notice, there's a second on the top, there's one on the bottom. They cancel out and you are left with just meters. So when you find the area, you multiply velocity times time units and you're left with just meters, which means if you can find the area under the graph, you are finding the distance that traveled. Total distance traveled is what the area under a velocity versus time graph will give you. Okay, so that's different. Slope, you have to divide the meters per second, that turns into meters per second squared. Area, you have to multiply meters per second times seconds. They cancel out and you're left with just meters. The question, how far did it travel from 0 to 2 seconds? From 0 to 2 seconds is from there to there. I need to find the area under that graph. It is just a square. So I am going to take length times width. I've got on one side, I've got 4. On the other side, excuse me, I have 2. To find the area of this, I just have to multiply the 2 and I get 8. It will be in meters because you're measuring distance when you do the area. All right, the last part, summarizing everything that we just had up above. Distance versus time graphs. The units for slope would be meters over seconds because it is distance over time. That means that the slope gives you the velocity of the object, and a flat horizontal line on a distance versus time graph, that means that the object is not moving. The distance is not changing, so you're standing still, you're not moving, you're in the same spot. The velocity versus time graphs, to summarize those, the slope of a velocity versus time graph is meters per second squared, because it's meters per second, and it measures acceleration. So it's telling you, are you speeding up or slowing down? A horizontal line, flat line, on a velocity versus time graph means that the object is moving at a constant speed or constant velocity. We use speed and velocity pretty much interchangeably. And finally, the area, when you multiply, that's when you take velocity times time. They cancel out. You're left with units of meters, so it represents distance. All right, that's kind of it for the notes this week. Kind of 3 things happening in class this week. Getting through the graphing notes, which you just did. There will be a second video to go with the cars lab. I'm going to film 2 different types of cars with 2 different types of motion. One is going to be moving at constant speed and one is going to accelerate. You're going to see and graph those types of motion. And then there's going to be a quiz at the end of the unit. Once you've gotten through everything, there'll be a quiz that will cover both graphing and the math skills that we did last week. So please let me know if you have any questions. Otherwise, thank you very much, and on to the cars lab.